Hi everyone, welcome back to the lithium cell capacity checker series. So in this video I'm going to do a few changes, and they're quite simple changes. I don't think there'll be any code in this video, but we'll see. So to start with, I had a transistor in here. In fact I had two transistors, and yeah, it was it kind of worked, but they just got really hot. And you know, transistors I don't think were the best choice for this. I don't really know why I chose them. Well, I suppose that it was simpler back when I started. But anyway, so I'm going to change it for IRLZ44N. And I think I only need one of these. One should handle it fine. So it turns out that the wiring, or the wire up if you like, is exactly the same. But on here we've got gate, drain and source. And I'm going to just keep the wiring the same. So we've got I'll just push it in there, hang on a second. So we've got gate, which is attached to the resistor, which is attached to the D2 pin, and then I've got drain, which is attached to the resistor here, so drain from, and then I've got source, which is source to the ground and the battery, or the cell. And in the past week, when I've been messing with this, it's been a nightmare. I've had all sorts of problems, well, not all sorts of problems, but I've had a lot of different issues, really annoying issues, which, you know, really erratic and sort of not easy to understand. But anyway, it turns out that the 2 or 3 problems that I had were all the same thing, and it was all to do with loose connections. So that problem to do with, you know, the lack of accuracy with the Arduino was down to loose connections. So make sure your connections are really strong in this thing. Now this is what I'm doing, and this fixes it. Now it's a bit crazy, but it does work. You see here there's this connection here between the battery or the cell and the MOSFET. If you just get one of these and ram it in there like that, I know it's a loose wire, but it makes sure that the wire is jammed into the contact in the breadboard. Anyway, so there's that. Now there's another change which I'm going to do, and it took me a while to figure this out, but then after I figured it out I was like, oh, of course. Now the other problem with accuracy is that the Arduino gets a different value from its ground to the ground or the cathode of the cell, and of course that's really obvious. Of course, because the cell here, the minus, goes here, but ground also goes here. But the ground of the Arduino is different to this ground, and the grounds aren't technically linked directly. There's this wire here, and if you add the resistance of both wires together, when we're measuring millivolts, that's a really big deal. So what we need to do is really simply take the ground from here out of the MOSFET and add the ground directly to the cell instead. So I'll go from ground of the Arduino directly to the cell. Okay, and now we've got a more direct link without having to go through the MOSFET and all that sort of stuff. We've got a direct link from the minus or the cathode of the cell directly to the ground of the Arduino, and that's better. It's much better. So there we've done the 2 changes, and I suppose I'll plug this thing in now, zoom out, and just demonstrate that it's working. So let's zoom out to start with, plug the USB wire in, and hopefully this will work. Oh, there's one more thing as well. I've got a resistor here, it's a 10k resistor, and I'm also going to put, you see the gate wire here, this green wire, the gate wire, that goes through the resistor. I think that's 270 ohm to the gate. I'm also going to put a resistor from D2 to ground, and the reason why I want to do that is because in the event that D2 is floating, in other words it's not high or it's not low, then what happens with the MOSFET? It doesn't know. It could be like 1 volt or something, or half a volt. But we don't want that. We either want the thing either on or off. We don't want it, you know, in some sort of limbo state. So we want it on or off. So if it was in a limbo state, then this could be like half on. We don't want the MOSFET half on. That's ridiculous, and it'll start the circuit and all that. So we don't want that. Anyway, so it says insert cell now and press run ready. So the first thing we'll do is check the voltage. So it says 3.78 volts, and what we should find now is we should find that we've got a lot more accuracy. So let's see. Right, so let's check the voltages now and see what happens. So it says the voltage is 3.72 and the voltmeter says 3.71. Oh no, 3.72, so that's really good. Let's say go and see what happens. So it says that the voltage has dropped to 3.12 or 11 or whatever, so 3.03, 3 volts, 301, and it's done. So we didn't really have long enough to check that cell, but the time we did spend on the cell, it was accurate. So, so I think we've accomplished that. I think we've got rid of the inaccuracy, and it's now pretty accurate. Now, just a bit of a bit more info. I have actually checked this with another cell, and it did work, and the accuracy really is resolved. Anyway, so here we've got the average amount of milliamps, then the duration, and then the milliamp hour count. So that's really good. Now let's move on. Okay, the next thing I want to do is add this buzzer. So I'll just push it in. I'll push the ground straight into the ground rail, and I'll push the other pin into the breadboard in a random place really. But then I'll push the green wire. I think we'll have D5 is taken, so it'll have to be D6. Yeah, push it into D6, and we will have to do some coding after all. So I'll go over to the PC now. Okay, so we're going to need one of these define things again. So define buzzer pin, and the buzzer pin was, did I say it was 6? I can't actually remember, just 1 second. Yeah, D6. So pin 6, buzzer pin, and then let's go down here. So we want to go to the finish code really. And not only do I want to go to the finish code, we want to do it when, well, not when the button is pressed, because if the button's pressed then the user already knows it's finished. So it'll be in the loop here. Right, so menu 4, main drain screen. Right, that's getting the user input. So over here is not getting the user input. Drain screen sample. Okay, drain screen sample, and then it does all the sampling. So yeah, here. So if the battery voltage goes below 3, then we automatically go over to display menu 5. So we can't put this bit of code in display menu 5 because when you click the button yourself and do it manually, that gets called also. So yeah, we'll put it here. So what should this thing be called? Buzz, I suppose. Buzz. Void buzz. Yeah, there are different standards here when you come to different programming languages. I find it really difficult. I suppose we should probably call it buzz. In C#, which is the language I'm used to, we wouldn't do that, but whatever. So what do we need to do here? So we need to set the pin high. So set pin high. We also need to do some output statements here as well. So output, suppose we might as well put this here. And is it called buzzer pin? Yes, it is. Buzzer pin. Buzzer pin is an output, so that's good. And then we need one of these. Buzz. In fact, I'm going to change that back down to lowercase b because I don't like that. Buzz. Then we want buzzer pin, and we want to write high. So the thing's done, we've just called it, so write it high, then let's say delay, delay for 1 second, then, I don't know, I suppose we'll have a break for a few milliseconds. So up to now that'll be going beep. Well, actually no, it'll carry on, so we need to say low now. So turn it off. So turn it on for 1 second, turn it off for 1 second, and then I suppose we want to repeat that a few times. So on for a second, off for a second, on for a second, off for a second, on for a second, and off for a second. That should do. It's not mega efficient, but it will do. It'll actually make this it'll it'll actually make the system hang for 3 seconds, but oh well. We'll test it out anyway. So Control T, Control S, and Control U. Let's see what happens. So this cell is already drained pretty much, so it's not going to take very long. So it's saying 3.1 volts. We're just going to wait for that to go down to 3.0, and then hopefully it'll start buzzing. It'll also hang at the same time, but anyway, let's see. So there shouldn't be much long now. 3.03, 3.02, 3.01. So anytime. And there we go. Okay, I swapped the buzzer over, and the other buzzer was quite a bit louder, so there we go, that's cool. Right, but the other thing I want to do is I want to make this a bit faster. I think 1 second is probably a bit too much. So let's make it half a second. So it should be beep, 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 and that should do. So, yeah, when I've done this, I'll go back over to the camera. So we've probably got about 5 seconds left, and then it should beep, and it should be a quicker beep this time. So 3.03, 3.02, 01, about now. Yeah, that's much better. Okay, so that's good. Now it's time to move on to the next thing. Okay, another change I want to do is I want to change the Nano for a Pro Mini. And the reason I want to do that is because the Pro Mini is smaller and it's cheaper. And it doesn't have the connection thing here. And, you know, if this thing's stuck in a box, you wouldn't need the connector anyway. I wouldn't need to spend as much money. I wouldn't need these indicators and all that sort of stuff. So the Pro Mini is better suited. So I've got a Pro Mini here. You can see it's smaller and whatever. So yeah, I've put this cable on here, this ribbon thing, and I put it on the other side and plug this in here. This is a Scilabs. Most people will call it a UART, but it's actually a serial to TTL converter and TTL to serial converter. And yeah, I've plugged this in and flashed it over to the Pro Mini, and now we have the sketch or the script or whatever you call it on the Pro Mini instead. So let's take that off, and here we go. So I've got one of these, and I've soldered some little header pins on it, like that, and this will do for now. So I'll just put that to one side, and let's make the changes. So I'll pull that out. So now I've done the rewire, and I've added this little thing in here. I've just pushed it in, and then I've like daisy chained the wires together. So I've put the plus to the VCC of this thing, which goes to this, and the ground to the ground, which goes to the ground of the Arduino. So I'll just zoom in so you can see. So that's what it's looking like now. Now before I wired this buzzer in, I wondered why it was quiet. Now as I was rewiring this thing, I figured out. Now the thing is that to get the ground here, because I was only using the LEDs, it goes from the LEDs to this ground rail, and then goes from the ground rail through a resistor to the ground. And that's the problem. So here we go through the buzzer, through the ground rail, through a resistor to ground. And yeah, so basically the buzzer isn't getting all of the voltage drop, it's sharing it with the resistor. So that's the problem. So what I'm going to do is I'm going to take that back out, take it out here, if I can take it out, yeah, there we go. And I'll take the wire out, and I'll put the wire, I'll keep it in the same row but just move it along. And then let's put the buzzer here instead. It's getting really fiddly now. Okay, let's put the buzzer there instead, and we'll have a wire from there to ground. So from, oops, I just pulled the little insulation thing off there. So we'll go from there to ground, and that should improve it quite a lot. About now. Yeah, that's much louder. Anyway, that's done.